These are the practice problems for lesson 4. And this first problem says that Clara says the two triangles are congruent. Triangle ABC and triangle A prime, B prime, C prime. And do you agree? And it's true, I agree that the angles are congruent. Because any similar figures, the angles remain the same. They are congruent. But the lengths have been doubled. So the image ABC is not congruent to ABC, but it is similar to ABC, meaning that each length, in this case, got scaled up by a scale factor of 2. So the scaling, you just draw arrows through each of the vertices, and the scaled image is twice as far away from the center of dilation as the original image. So the length to B prime is twice as far as the length from D to B, and so on throughout. So the triangle is scaled, but it is not congruent. Each length gets doubled. So here they are just colored in so you can see them. And notice once again, I want to continue to make this point. As you go from the center of dilation, each side remains parallel. So this side is parallel to this side is parallel to this side, and this side is parallel to this side. Okay, the next problem. There's a series of dilations. You're supposed to take this figure through, this quadrilateral. The first one is the center of dilation is at R, right here, and the scale factor is 2. Well, if the scale factor is 2, and this is the center of dilation, you're going to draw arrows from the center of dilation through each vertex, and it's going to end up showing you where double the length is. So double the length is going to take you to here. Double this length, a little bit harder to see on this one, so you could count. Actually, let me show you the answer first. And double the length to this one. This is a little bit harder to see. I guess this is 1 unit, or I'm sorry. So this is 1 unit, so this entire length would take you out to here for 2 units. All right, and you could check by counting. Go back a little bit. So the scale factor here is 2, so I could count up 1, 2, 3, and over 2. That means the scaled point is going to be, instead of 3 units, it's going to be 6 units up, 1, 2, 3, 4, 5, 6. And instead of over 2 units, it's going to be over 4 units. 1, 2, 3, 4. And you could do that same kind of counting for each one of these. You connect each vertex, each angle, and you get the scaled quadrilateral. The third problem, oh, actually, I'm sorry, there's 2 more parts to this. It says using O as the center of dilation and a scale factor of 1/2. So now you're going to start at the center of dilation, which is O, and draw arrows or connect these points. And that's going to tell you what length gets cut in half. So connect each of these points. And so half of this length is right here. Half of this length is right here. And this one is probably useful to count for this one. So if I count out 2 units, half of 2 units is 1 unit. If I count out 1, 2, 3, 4, 5 units, half of 5 is 2.5. So this is going to go out 1 unit and up 2.5 units. So halfway is right there. Halfway, this one's a little bit easier. Halfway is right here. You could count out 1, 2, 1, 1, 2, 1. So this length is 1/2 of this whole length. And this length, right here, this one's hard to see also, is 1/2 of this whole length. So you can see that this is 1, 2, 3, 1, 2, and then go another one of those, which is another half, is 1, 2, 3, 1, 2. So actually the total would be 6. 1, 2, 3, 4, 5, 6, and up 4. 1, 2, 3, 4, and half of that's going to get you to this point right here. Just have to get used to figuring out where those points are. Then you connect each of the points, and you get the scaled quadrilateral. That's a scale factor of 1/2. So each length is 1/2 the size, but notice that each angle remains the same. So each angle is congruent, and notice that each of these sides are parallel with the dilated side. So this side is parallel to this side, this side parallel to this side parallel, and this side parallel. And the last one says you're going to use center of dilation as S. This point right here is going to be the center of dilation and a scale factor of 1/2. So each of these points are going to be brought in along their sides by half the length. So this one is half the length. It's going to go right here. This one's half the length, so it's going to go right here, actually. And this one going this way is half the length, and this one would be useful to count. So this is 1 unit out this way. So half the length, half the length. So 1 unit out this way, so half of that is 1/2 of that length, and it's 1, 2, 3, 4, 5, 6 units this way. So it's going to be 3 units along the horizontal axis. So this is 1/2 and then 3. 1, 2, 3 gets you to right there. So it's a nice way of checking, are you placing the points in the proper spot? And then you connect them and you get the scaled quadrilateral with a scale factor of 1/2. And notice one more time that these lengths are parallel, these lengths are parallel, this length is on the same side, this length is on the same side, so obviously those are parallel. All right, the next problem number 3, says find the missing angles. Now these are not parallel lines, so you can't use this idea of alternate interior angles. You really have to do each one of these independently, each one of these separately, but that's okay. You know that they're vertical angles, and you know that there are supplementary angles. Angles that are supplementary are 2 angles that add together to equal 180 degrees, and the angles through the intersection are vertical angles. So 2 angles not equal, lines not parallel. So vertical angles, this angle has to be 35 degrees, and this vertical angle here has to be 27 degrees. And then supplementary angles, 35 plus 145 degrees equals 180 degrees. And notice that the 145 degree angles are also vertical angles. So you can get that way as well. And here, 27 degrees plus 153 degrees equals 180 degrees. So those 2 angles are supplementary. And again, this angle is a vertical angle to 153 degrees. So this angle is 153 degrees. So vertical angles and supplementary angles. Problem number 4 says, describe a sequence of translations, rotations, and reflections that takes polygon P to polygon Q. So one thing is to do that transformation in one step. It says show a sequence, but you can do it in one step because it is a rotation. It's actually a 90-degree rotation. You get an idea of that by looking at this point here compared to this point. If you drew this out this way, and if you drew this down this way, you're going to see that they meet here. So this is probably the center of rotation. So let's check that out. So if I connect corresponding points, so this point here corresponds with this point here corresponds with this point corresponds with this point. You have to kind of follow them carefully. I'm not doing all of them because that would be way too messy. All right, so if I think that this is going to be the center of rotation, but all I have to do is find the midpoint between these 2 corresponding points. And that's right there. Then I just have to draw a line that's perpendicular from that midpoint, from this line that connects the corresponding points, a line that's perpendicular, and it's going to intersect at the center of rotation. So you can tell which is perpendicular because it's using this diagonal and this diagonal, so that's 90 degrees. So that's perpendicular, and you can check a few of these others. And so you find the midpoint, and from that midpoint you draw a line that's perpendicular. They will all intersect at the center of rotation. So this is the midpoint. This is a line that's perpendicular, goes to the center of rotation. This is the midpoint. This is a line that's perpendicular, goes to the center of rotation. This is the midpoint right here between these 2 corresponding points. This is a line that's perpendicular and intersects at the center of rotation. And then just for fun, first of all, to find the center of rotation, connect a few corresponding points. You don't want to do a lot. You only need a few. You actually only need 2, but you want to check it with maybe 3 or 4. Choose points where the midpoint is easy to see using the grid. So this midpoint's easy to see, this midpoint's pretty easy, this midpoint's easy, this midpoint's pretty easy. So using the grid, and then draw a line that's perpendicular, which means a line that's 90 degrees from the midpoints, and they will all intersect at the center of rotation. So now, just for fun, 90-degree rotation around this point. All right, I connected all the corresponding points just for fun. And this is the beginning of what string art looks like. If you've ever seen a bunch of string art, this is what they're doing. They're taking two images that have been rotated or reflected in some way, and they're just going around and connecting all the corresponding points, and they get these nice designs. Looks kind of messy, but if you colored it in and cleaned it up a little bit, it would be a nice design. Now I could take this image, translate it to this point right here, and then rotate it 90 degrees around. And to rotate it, we could count to make sure. So if I start at the center of rotation right here and count up 1, 2, 3, 4, and then rotate that 90 degrees and count 1, 2, 3, 4, this point is going to go to this point. I do the same thing with this point. Count up 1, 2, 3, and then over 1, 2. I'm going to rotate that 90 degrees and count out 1, 2, 3, and up 1, 2. So that goes right here. You can do that with every single point to check. Pretty soon you can just use the image to figure out where the points go just by counting and using the grid. So that does rotate to right there. All right, the last problem. It's a series of translations. You're going to start at -2, -5. And it says after a translation of 4 units down, so we're going to go 4 units in the negative direction. So it's still out -2 units. So the x value is still going to be -2, but it's going to go 4 units down. So that's a -4, a -5 plus a -4. So it's going to go to -9, which is going to be right there. And then it says a reflection across the y-axis. This is the y-axis. So you're going to reflect this point across the y-axis. It means you're going to move in a perpendicular direction to the line of reflection, and it's the same number of units on the other side of that line of reflection. So this is 2 units, so it's perpendicular or 90 degrees. So it's another 2 units, so it's going to go to that point right there. And it says any translation 6 units up. By the way, this point now is at a +2, -9. This is -2, -9. But a reflection, if you remember, you're turning the opposite direction along the x-axis up here. Instead of going -2 units, you go +2 units, but the y value still remains the same. It's -9. And now translate 6 units up. So 6 units in the positive direction, let's say taking -9 and adding 6 to it. So a -9 plus 6 is a -3. So 1, 2, 3, 4, 5, 6. So you end up here at -3. So it goes right to there. So the coordinates are going to be a 2, -3, and that's where B prime ends up. So a nice use of subtracting and adding positive and negative numbers, and we could think more about that later. All right, these are the practice problems from lesson 4.